Hey everybody, if you don't know me, I'm Alex. I work in the META Lab, and this is the Geek Out on SQL, or SQL, which is called Structured Query Language. That's what it stands for. And just to start off with a bit of a disclaimer, this is a bit of a weird Geek Out because SQL is almost completely useless for anything we do at school, but it is the most important thing to know if you ever work at basically any company. So SQL is used as to query databases and very large databases with many different tables all interconnecting and relating to each other. So as a result of that, it costs a lot of money to run those databases and to set them up, and database architecture is a whole other thing that Carlos can tell you about probably next week at the Geek Out, next week, a little bit about at least. So as a result, things like R and Tableau and Python are much more useful for us at school. But then when you go to a company, say like a tech company that has millions upon millions upon millions of rows and keeps them in 400 different tables, you're going to be using SQL to get any of that data. As a result, what I'm going to do today is show you guys some SQL syntax using a browser-based sort of like SQL demo website. It's called dbfiddle, db-fiddle.com. This is where I want you all to go to. And it should say MySQL version 5.7 up here. There are a ton of different SQL syntaxes, like there's Postgres, there's SQLite, there's MySQL. There are like 9 different versions of each of those. There's Oracle SQL, which I used for the first time this past summer, which was fun. They're basically the same syntax with a couple of tweaks. Right now we'll use MySQL, which is the most widely used. You see up here the schema. Schema just means the database. It's just like the map of the entire database. That's what that means. So to start off with, if you guys have opened this file already, if you could just copy the whole thing and then paste it into this left side over here. So this is a data set called Gapminder, which I used for the R Geek Out, if you guys came to that. It's essentially just like a play data set that has a bunch of like life expectancy, population, and economic data for a bunch of countries throughout the world for several years. And as you can see, this is how you actually create a table in SQL. It's a bit of a pain to do for anything that we would normally do it with, which is why it's you know, this is for like using in a big enterprise setting. So once you've got that copied in, if you could just click run.
Where would I get the Google.com?
Oh, it's at that link on the bottom there, tinyurl.com/SQL Geek Out, SQL Geek Out. And if it runs correctly, then it should say query successfully executed. Did everyone get that? Is everyone able to do that? I'll give it a couple seconds. Try to zoom in a bit. Since a couple people just came in, oh, Carlos, you got it? Cool. Thanks, man.
That's just going to have one bit of PC on the screen. So that's in the after that, go to the website db-fiddle.com. And that's where we're really at.
Is that? Let's see. Just trying to get to the spreadsheet. SQL.
Oh, cute.
Yep, no worries. I'll give it another minute to get this.
I have a question.
Yeah.
So, for us to put this information, if we're doing this for a job, for us to put this information, does it have to look like this? That's in the Excel sheet, the text sheet?
No, so this is, in this document right here is SQL syntax for creating a table. But normally, when you're at a job, the data will already be in a database somewhere. And you will then be going in and grabbing that data in certain ways, like certain amounts of it, like aggregations of it. So usually you won't be actually doing this in a job setting, this creation of a table. But because we don't have a database to play with, this is what we have to do.
Yeah, and normal also too, most people have, rather than directly work on script, you can probably interact with it via scripts. So rather than, because this is like straight command line prompt. So you open your command line prompt, you insert all this in the database. What you could also do is have scripts. So like when somebody creates something in a database, right, they fill out forms or things like that, and you grab those forms, grab that data, and insert it straight to the database. So you don't, it depends who the developer is,
right.
But you can either A, work straight from the command line prompt. So this would be a command line prompt. Like you open your command prompt, copy and paste that, and it goes straight to the database. Another way is via scripts. So imagine if you're a developer, you create some type of script where you have a nice little form field, like insert your name, last name, address, whatever the data is. And when people press submit, you essentially have a script that'll take that form, all the data you put in that form, and reformat it into something like code values, and then that gets sent straight to the database.
Yeah.
Then there's like GUI platforms, like drop down to stuff like that, that essentially tries to recreate that. So there's a variety of ways to interact with database. This is like step one, like this is what actually is going on.
Yeah, that's a good point. Thanks, Carlos. Most of that stuff, so like, say, like I worked at Uber, and what they'll do is when someone takes a ride in a car, the database engineers will put together a script that takes that data from the phone and then turns it into this. And it will insert it into the tables that they have. That's a database engineer's job, though. As like an analyst or something, all you'll be doing is what's going to be over here on the right. Because I doubt anyone but Carlos is going to be a database engineer here. Okay, is everyone able to get that to get the script to run? Cool. All right, so on the right here, there's a different window, and this is where we're going to be writing the queries to get data that we want to see. So there are a few main parts of a SQL query. There's the select statement, which selects columns that you want to look at. So in this case, we're going to do an asterisk, which just means everything. And then you have to say from Gapminder. Gapminder is the name of the table. So this is the most basic query you can run in SQL. And if you click run, then you'll see all your data pop up down here. If we want to see just one column, we can do country. We just replace the asterisk with country. And you get one column. You can do multiple columns, so let's do country, continent, and pop. So comma separating them, except the last one, which does not have a comma.
so you're right, you're selecting 3 columns.
Yeah. Yep.
Content and top.
Make sense so far? Cool. The next part of a SQL query is the where statement or the where clause, where you can put in conditions. So if we have our 3, let's actually just do country and pop. Country, year, and pop. We can say, let's filter this so that we only see the rows with year more recent than 2000. So to do that, you do where year is greater than 2000. Hopefully this works. Yeah. You can do this with any column. So you could do where pop is greater than, let's say, what, 30 million? 1, 2, 3. And you can string together multiple conditions with and. Let's do years less than 1980.
Also, does order matter? Like for instance, you have to select first, and then you say from database. For instance, so if you were to accidentally put and where on the top, it'll screw up the whole thing.
Yeah.
So always select.
Yep.
Then from.
Then from.
Then there you put your operators.
Your
where,
join and where and order. Yeah. So, yeah. So this is like order is important with this stuff. So you always have to have select first, and you always have to have a from, and then you can do your different sort of filtering and operators. Any questions so far? Cool. Okay, so you can also do aggregations. So we're going to delete these conditions for a second. If we want to just find the, let's say the, I don't know why you would ever want to do this, but let's try to find the total population for a specific year. So you can do sum pop from Gapminder, and then where year equals, let's say 1957. Sorry. Might have to do one equal sign. Yeah, there we go. 1 equal sign. Got my languages mixed up.
Yeah.
So where year equals 1957. Was that like 2 billion? We can see how many countries they have data for in 1957 by doing count country. So they have data for 142 countries. Not bad.
And we do like aggregation functions like this. You would always have to do it that way. Like you can't do select these columns first, and then from these columns you put your count, sum.
No, you have to do aggregations up front, as far as I know. There might be like a sort of hacky way to do it later on, but so if like to get into it a little more, let's say we want to find the sum per country for what we want to do. We want to find the average life expectancy per country over the course of the entire data set. You would do ABG, life expectancy, and then comma country. Let's delete the where. So when you have an aggregation column and another column, what you have to do is group by the non-aggregated column. So you have to break up the data set into groups based on the column that isn't being aggregated, if that makes sense. To do that, you do group by country. It's a weird quirk of SQL where you can't actually, where you can't show any column except the aggregate column unless you group by. So if we want to see the data ordered by average life expectancy, what you can do is ordered by average. Oops. There we go. Ordered by average life expectancy. And default is ascending. If you want to do descending, you can just add a DSC after the variable name, after column name.
Do we have a list of these functions that ordered by average and DS somewhere?
I mean, you can find them online pretty easily. I don't have a specific list.
Yeah, since we're using MySQL, MySQL probably has documentation. So if you go to
Yeah.
MySQL, let's see MySQL documentation. Usually every database have their own documentation manual. So let's see, dev SQL docs. So
What I'm doing right now, the slash then asterisk starts a comment. So comments won't be run; they're just ways to leave notes to yourself. And you have to have one at the beginning and one at the end.
Can you do inline comments?
Yeah. You can also, the other aggregate functions are things like maximum, minimum, there's a median function, let's do max life expectancy per country, and let's do that. And then order by max. So we can see that in this data set, the highest life expectancy was in Japan with 82.603. So one of the annoying things about SQL is that you can't just see what year this is, because you would have to, like, you can't just pull up the year column as well alongside this. So what you have to do is you would have to run another query. So let's do that. Let's do country year from Gapminder, where country equals Japan, and life expectancy equals 82.603. That's fun. Let's just more fun SQL stuff. I think there's something going on with the max function, which is rounding it in a weird way. Let's just do life expectancy greater than 82.6. There we go. There we go. That's how you do it. So the reason why equals wasn't working there is I think that life expectancy is rounded weird, and equals forces an exact match. But this is, so when I use SQL, when I used SQL at my past internships, a lot of what I was doing was, looking up things that met a certain condition, and then having to go do another query to figure out the rest of the columns attached to that thing that I was looking at. So just like we did, we found the max life expectancy for the entire data set, and then we had to go run a different query to find all the information about that max life expectancy. So the country column is a string column, which is a little bit different when doing conditions and comparisons. But it just means that for the most part you have to wrap the name in quotes so it knows it's a string. So that way you can pull up all of the entries from Japan. You can do funny things with strings as well. If you want to, say, match only part of a string, so you can do like, use the operator like, where country like, and then the percent sign just means anything. Something that I found really useful is if you have a very messy column that has like multiple different schemes of like lower and uppercase, what you can do is search like this for any letter. So that'll take into account, if one of these columns is a lowercase j and an uppercase j. In other words, isn't consistent. You can stick the percent sign on either side. I don't know if it's yeah. There we go. So this will just match any word that has AM in it. You can stick it on the inside if you want to. There are like 3 or 4 different ways to do conditions in SQL. The main one is where, but there's also one that you can put in the select statement itself, which is using case when syntax. So this is, sorry, go ahead.
Just a quick add. So you guys want documentation on where these commands are found. So if you go to dev.mysql.com, select documentation, click MySQL Server since that's what we're dealing with, and then go under functions and operators. So if you go to dev.mysql.com, select documentation, and then go to MySQL Server, and then under MySQL Server, you guys see like the left hand side is going to be a whole bunch of stuff. Look at operators and functions. I think that's what they label it. And then there it'll show you the command. So if you look at string functions, you'll see stuff like.
Yeah.
If you go to logical operators, those are like comparison stuff. But that's the website where you guys can, if you guys are interested in looking at like.
Yeah.
Thank you. Thank you.
So case when is another logical operator or comparison. Do that. You can do case when life expectancy is greater than 80, then so it's case when, some condition, and then else. You can do multiple case whens too, but we're just going to do one. Then else, and then you have to remember end at the end of that. So you can see that it pulled up this.
Is this like creating new information?
Yeah.
For
So if you want to do some sort of modification on the data and then have it show up based on that, then this is how you do it. Ever been able to do that? Make sense? You can do multiple of these too. I'll actually go through this.
So case one goes together. So we're saying
Oh, sorry.
life expectancy is greater than like was that 80?
You just need one case.
Alright, so what does case stand for? Like when this case specifically?
Yeah, so it's essentially the same as if.
Okay.
Yeah. Okay. Then to do like finding a number between two other numbers, you can do when life expectancy between. Let's do like 50 and 80. Then we'll just change this to lower than 50. So now we have 3 conditions, right? Let me do this.
Is that between selection, like that case, is that inclusive of 50 and 80 or exclusive?
That is a really good question. Actually, it is inclusive.
Okay.
Yeah. Okay. Does everyone able to get that to work? Everyone good? No?
I'm wondering why do we need to put from get minder at the end, because I tried at the front end didn't work.
So it's just the way that SQL is built. The order of the commands matters. So from getMind, like from the table, always has to come right after the select statement.
Mm-hmm.
And this whole thing is the select in this case. Did you put getMinder up here before the case?
Yeah.
Yeah, sorry. So the case is still part of the select statement. The case to the end, this bit is essentially building a column. It is the same as this or this. It's just doing it based on conditions rather than a name.
Alex?
Yeah.
Do you also, without the comma after life expectancy, it doesn't run?
Yes. Which is, it's because this is a column it's building. Yeah. Good call. Yeah, so you need this column after life expectancy right here.
I have a question. How do you change the title of that column?
You can do what are called aliases. So if you want to change country to
Oh no, I mean for the case, because I'm like seeing all the command for
let's do I think this goes. Yeah, there you go. So you do as, and then whatever you want the column to be named after the column in the select statement. So if you want country to be called country with a capital C, you can do that. That changes it down here. Any other questions? Were you guys able to get it to work? Cool. Awesome. All right. I'm going to comment this out. I'm not going to delete it, but I'm just going to comment it out and then do something else down here. Okay, so let's say we want to do some basic, like looking at other groups. Like let's say we want to look at the average life expectancy per continent. Then what we can do is life expectancy continent. Let's do, sorry, AVG, life expectancy continent from Gatminder, group by continent, order by average life expectancy. Oops. Actually, I am going to delete this. I'm going to put this in the Word document with all the data. I'll put it at the top so you guys can refer back to it if you want.
So you have to start from a clean slate every time you want.
No, it was just I had too many comments in there, so the comments were conflicting with each other. So there you go. If you run this, then you'll see average life expectancy per continent. If we want to do per year per continent, you can put in multiple columns into the group by. And the order in this case matters, so I'm going to put year after continent. So it groups by continent first and then year. Sorry, that's a... And then you have to remember to put the year column in the group by. And if you run that, you can see the lowest average life expectancy and what year that showed up in. You can do this with anything, so if we wanted to see it broken out by country and continent, you can just put country in there. Let's see. Make sense? Cool. All right, one other thing that I should show you that's important, especially for companies with tons of tables, is what's called join. So when you have like two tables and they each share a column, but they have different data, then what you can do is join one onto the other. If you do any R, you might have done this with like merging tables, and there's actually a join command in R. But this is really important, and since we don't actually have two tables, what I'm going to do is do a self join. So you can join a table to itself, which is fun. So we're going to delete this, and we are going to
Is that a dot country?
yeah. So what I've done here is I've named the table. I've given the table an alias called A.
Oh, so that's a shorthand for, so instead of writing as alias.
Exactly. So the first two columns are going to come from this first, like the A table. The one with B is going to come from a B table, which we're going to create in the join. So this is how you get multiple columns together into the same table. The syntax for join is just join, and then it's on. So join will take the table, and then on is telling SQL which column you want to join on. So if two columns have identifying, like ID numbers, then it would be table1.id equals table2.id. In this case, we have to build a table and join from our other one.
Is that gapminder A?
Yeah.
Or gapminder dot A?
Gapminder space A. Right here? Yeah.
Got half bar in here. I'm gonna analyze it out.
Okay. So what we're going to do is called a subquery. It's the same thing, just in parentheses. So we're going to do select let's do country. Actually, how am I going to do this? I'm just going to show you this for now. This is a little funky, but let's do from gapminder and then as B. So that as B is telling SQL that this new table is going to be called B. Actually, let's throw a where in there. Equals 52. We're going to throw the year in there because that way we know that there's only going to be one row per country. And then what we're going to do is on A dot country equals B dot country.
Do you not need life expectancy in the select variable?
Oh, good call. I forgot that I was using life expectancy. Delete pop, put life expectancy in there. And if you run that, then you'll see that you now have 3 columns. Does that make sense? I know this is a little weird because we're only using one table, but just imagine that this is an entirely different table with different information. Let's actually throw a where in here as well. Tools. There you go. So without that where, that bottom one, what it was doing is it was copying the life expectancy data from 1952 for every single year. There are several types of join. So the default one is left join, left inner join. So what left inner join does is it keeps all the data from the left side, which is the first table that you named. It's actually left outer join is the default. So left outer join keeps every data set or every row from this first table, but it only keeps the rows from this second table that match. Does that make sense? So if you have an identifying number in the first table and you have 3 identifying numbers in the second table, it's only going to keep the one that matches. There are other types of join, like right outer join will do the same thing, except I'll do it for this second table. Then there's a full outer join, which will just keep all of the data in both tables. And then there's an inner join, which will only keep the data that matches in both tables. So if you have 3 ID numbers in the first table and 3 ID numbers in the second table, and only one matches, then an outer join will only keep that one. For the most part, left outer join is the one that you'll use. There are other things, so I'm going to wrap it up here, but just I'm going to put in comments a couple other commands that you can look up. So there's unions. There is having clause, and there are just like subqueries in general. But honestly, like 99.9% of the queries you'll run in like a normal analyst role, if you work at a company that uses SQL, will just be like this. Like I know this is a lot to take in an hour, but this is really the extent of it. There's not much more. What I'll do often is run a query like this in a SQL database and then export the data that I get into a CSV to then use in something like R, because R can't handle giant data sets, giant databases, but it can handle CSVs like this. So what I'll do is I'll make a CSV by running a SQL query and then analyze it in R.
So is there like a specific export command?
It depends on the program that your company uses. Usually they'll have a button that's just like export a CSV. You can't export it straight out of SQL. Cool. Any other questions? In that case, oh yeah, so.
So to remember all of these, I guess.
Operators, functions.
Yeah, the functions we would have to go to the mysql.com to.
Yeah, there's not really a good list. There's some cheat sheets online that you can look up as well, but
yeah, and I would say like all the kinds of operators follow the same ideas. So I guess look into trying to understand the difference between what's a logical operator, what's a comparison. Because even in NoSQL, they have the same like logical operator, comparison operators, and they follow the same idea. I mean, how you write the command is slightly different, but once you learn like one database, like, all right, this is what they mean by logical or conditions, or however people want to phrase them, it would technically follow the same rule for all databases.
Yeah. So logical operator is just anything that is essentially asking a yes or no question, for true or false. As for like actually remembering what these functions do, it's a lot of trial and error. It's a lot of looking at documentation. There's not really just a good list of this stuff. Like having a previous query to look at to remember how this works is the best is how I learned. So I would just build one by looking at the documentation, and then just use that one to build all the rest of my queries off of it. So it takes practice, but SQL is, in my opinion, the most approachable of like data analysis languages, because it is so like compartmentalized and you know, pretty strict and pretty limited in what you can actually do. But it so happens that everyone uses it. One day they'll all change to JavaScript and NoSQL, but
Yeah, I mean, SQL's been around longer. That's why everybody's using it.
Yeah.
Rows and columns.
Yeah.
As soon as they'll see the beauty of JSON.
yeah, next week, if you want to see what NoSQL is all about, come to Carlos's Geek Out. That's next week, right?
Yeah.
Right. That's it all. Thanks for coming. Appreciate it. Hope you learned something interesting, something useful.